Here we're looking at the concept of probability, and probability is central to inferential statistics. The aim of inferential statistics is to discover whether results are statistically significant. A significant result is one that is unlikely to have occurred due to chance. Usually, psychologists use the 5% level. This means that just 1 in 20 of results could have occurred due to chance. We express our results in terms of the null hypothesis. If a result is statistically significant, we can reject the null hypothesis. If the result is not statistically significant, we must accept the null hypotheses. In other words, we need to be 95% confident that the results were due to the manipulation of the independent variable in our experiment in order to reject the null hypothesis. In general, if you're carrying out an experiment, your null hypothesis would say something along the lines of, any change or difference between your two experimental conditions is due to chance. The concept of statistical significance is linked to the mathematical concept of probability. In its simplest form, think of the probability of tossing a coin and it landing heads up. The probability of that happening is 1 in 2, or 50%. When gamblers talk about odds, they are really talking about probability. In psychology, the most common level of significance is 5%, or 1 in 20. And it is expressed as P is less than or equal to 0.05. The P stands for probability. This level is seen as representing a balance between a type 1 and type 2 error. 5% level is fine for psychology, but clearly, if we were experimenting on a new drug, a 1 in 20 chance that it might kill you wouldn't be very good odds, and the level would have to be significantly reduced. A type 1 error is also known as a false positive. This happens when we reject the null hypothesis when there is a possibility that the results were in fact due to chance, often caused by using a significance level that is too lenient, for example 10%. A type 1 error is all about not being cautious enough. Imagine a doctor telling a man he's pregnant, clearly a false positive. A type 2 error is a false negative, accepting the null hypothesis when there is a possibility that the results were in fact significant. This is often caused by using a significance level that is too strict, for example 1%. So a type 2 error is about being overcautious. Imagine a doctor telling a clearly heavily pregnant woman she is not pregnant. If we have a statistically significant result, it is a result that is unlikely to have occurred due to chance. In fact, we can be 95% confident that it was not due to chance.